We're in geometry now, so we've got the Pythagorean theorem basically just mastered, right? So we're going to talk about something with it, and then its converse, and somehow we can tell whether a triangle is acute, obtuse, or right by using the Pythagorean theorem. And normally, all we can use it is for right triangles, right? If I'm missing a side, I can use the Pythagorean theorem. But we're going to find out here shortly how it's going to be able to tell us acute or obtuse. So first things first, we have a new term, a Pythagorean triple. And I know some of you are familiar with some of these, but it's a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals. So basically, as long as it works to make a Pythagorean, or as long as the Pythagorean theorem works to make a right triangle, you got a Pythagorean triple. And here are some really common Pythagorean triples. Our most common ones are the 3, 4, 5, and the 5, 12, 13. So basically, any right triangle that has that ratio of sides, we could say it's a Pythagorean triple. So for example, if I look at the 3, 4, 5, just think if I multiply these all by 2, 6, 8, 10, if those are three sides of my triangle, it would be a right triangle, because if I plug those into the Pythagorean theorem, if I took 6 squared plus 8 squared equals 10 squared, it would work, right? I know it's a right triangle. So any multiple of 3, 4, 5. So even if I multiply these all by 3, 9, 12, and 15, right, they're all based off of that 3, 4, 5. So anything, if I take 3 times something and 4 times something and 5 times something, as long as I take them all times the same number, it's going to be a right triangle. It has to be, because 3, 4, 5 is a right triangle. And the same thing works for the rest of these. So for example, 10, 24, 26. So basically 5 times anything, 12 times that same number, and 13 times that same number. And the same works for those other two. Except 3, 4, 5, and 5, 12, 13 are kind of our most common. 8, 15, 17, 7, 24, 25. Yeah, they're kind of common, but 3, 4, 5 is the biggest one. Well, find an x. Okay, we've done this for a long time. The only thing different about it, so a squared plus b squared equals c squared. Hypotenuse is always a c. So it doesn't matter if I put x squared or 25 squared first, but x squared plus 25 squared, or 25 squared plus x squared equals 26 squared. Let's just take a look how we're going to do this just a little bit different. So 25 squared gives us 625, and 26 squared gives us 676, tough to say. So when we subtract 625 from both sides, we end up with x squared equals 51. So what we want to do is take the square root, right, to find x. Cancel out that square. So x equals, let's get it in simplified radical form. Well, the only two factors of 51 are 17 times 3, right? And neither of those are perfect square factors, so this is actually in simplified radical form. So let's say x is the square root of 51. Don't round it to a decimal. Let's get used to simplified radical form, right? It's good practice for us. The converse of the Pythagorean theorem, and you've done this before as well, if I'm given three sides of a triangle, if I plug the biggest side in for c, and I use the Pythagorean theorem, a squared plus b squared plus or equals c squared, and this works, right? If I get an answer like 250 equals 250, okay, that means it's a right triangle, right? If it works, it's a right triangle. And we've done this before. We have two other theorems, though, to find out if it's an acute or obtuse. The Pythagorean inequality theorems. Well, if I use the Pythagorean theorem, and I put the largest side in for c, and the a squared plus b squared happens to be greater than the c squared, I know it's acute, because I know the biggest side is a little bit smaller. I know it's acute. Well, if the a squared plus b squared is smaller than the c squared, I know that the biggest side is really long, and so now I know it's going to make an obtuse angle. Okay, so basically if the Pythagorean theorem works, it's a right triangle. Right, if the a squared plus b squared equals, if a squared plus b squared is greater than c squared, it's acute. If it's less than, then it's obtuse. Those are our three little rules here. Let's go ahead and try one. It says determine whether each set of numbers can be the measures of sides of a triangle. Well, this can be, right? Any two sides have to be bigger than the third side. If so, classify the triangle as acute, right, or obtuse. So to check Well, 13 is my biggest, so I'm going to make that c. So I take 10 squared plus 11 squared equals 13 squared. Actually, right now I don't know what sign's going to be in there, so I'm just going to leave a little box, I guess. So 10 squared is 100, 11 squared is 121. Don't know what sign yet. 13 squared is 169. Well, 100 plus 121, that's well over 169. So if a squared plus b squared is greater than c squared, I know that the largest side is a little bit smaller, so I end up with an acute triangle. And if I look back to my theorems, that would have been this guy right here, right? If a squared plus b squared is greater than c squared. It's an acute triangle. So there we go. You're just comparing the numbers at the end. And really, that's all there is to it, okay? Pythagorean theorem, you guys know that. So just using those last two theorems to figure out if they're acute, obtuse, or right.